Well, hello there, boys and girls. Today we're going to take a look at something called the chain rule. And before I show you what the chain rule is, I'm going to show you a motivating question or a motivating example. Let's say which one we want to find the derivative of 2x plus 1 quantity squared. And let's say that we think this is equal to 2 times 2x plus 1 to the first power. I'm going to put a question mark right here because it's not really true. And that's our typical power rule. We bring the 2 down and we subtract 1, right? This works out to be 4x plus 2. Well, why is this wrong? The reason this is wrong is if we were to expand 2x plus 1 out, we would get 4x squared plus 4x plus 1. You just go ahead and FOIL that out. And then you take the derivative of that, and we get 8x plus 4. And this is the correct derivative of our original problem. Now, how far off was our original guess? Well, if we were to take our original guess and multiply it by 2, we would see we get the correct answer. And 2, this missing factor, happens to be the derivative of this inside function. So we've taken derivatives of things that have been pretty simple before. We've taken the derivatives of like x plus 1 squared, and that would be simple. That would be 2 times x plus 1. But what happens if we have a coefficient on the x, or if what's inside the parentheses is a little more complicated? We have to invoke something called the chain rule. So here we go. I'm going to show you what the chain rule is, and then we're going to go through several examples. If we have a function that is inside another function, this sometimes is written as f of g of x. That's what that fog means. F of g of x. F of g of x. That's prettier than that. That's ugly. This is pretty. Alright, so anyway, if you have a function inside another function, then you have to do the chain rule. And the chain rule looks like this. Find the derivative of the outside function, the f, and leave the inside function alone, and then multiply that times the derivative of the inside function. Another way to think about this is if you had y as a function of u, here you have u as some function of x inside another function, then dy dx is the derivative of the outside function times the derivative of the inside function, and this is Leibniz notation for dy dx. Newton is the one that used what's called fluxions, or this little prime thing. This is Leibniz's notation, and you can see that the du's cancel and you get dy dx. I know that's really confusing. Let's look at some applications of this. Find the derivative of 2x squared plus 4x minus 1 all to the third power, and we can see that I've got a function inside another function cubed. So my derivative is going to be 3 times 2x squared plus 4x minus 1 to the second power. That's the derivative of the outside function. That's the derivative of a cubed. But then we're going to follow this up with the derivative of the inside function. And the derivative of this inside is 4x plus 4. And that's why we have what looks like is d. Take a look at another example. Here I've got 2 minus x inside of a squared, so we're going to do the derivative of that. So f prime is going to equal negative 4 times 2 times 2 minus x to the first power, and then we're going to multiply that times the derivative of the inside function, which is the derivative of 2 minus x is negative 1. Then we're going to go through the derivative of this is going to be 5 times negative 1. It's just 5 times the derivative of the inside function, and of course the derivative of 9 is 0. So let's see if we can clean this up at all. This is going to be a positive 8 times 2 minus x and then minus 5, and it looks like our answer is D. Now let's keep going. Here I've got a function inside another function. You could rewrite this as 3x squared plus 2x to the 1/3 power. So I've got f inside of g, or g inside of f, however you want to look at it. So our derivative is going to be the derivative of the outside function. So bring the 1/3 down and subtract 1 from that. That's negative 2/3. And then times the derivative of the inside function, which is 6x plus 2. So let's see, is that, it looks like that's B. Not doing too bad. Okay, what about trig? Alright, here I've got the function cosine, that's the outside function, and on the inside I've got t over 3. So my derivative, or s prime of t, is going to be the derivative of the outside function, which is negative sine of t over 3, and then times the derivative of the inside function. And if you think about this as 1/3 t, the derivative of that is 1/3. So I've got negative 1/3 sine of t over 3. Let's do a more complicated example. Cosine squared x means cosine x all squared. So you can see I've got a function inside a function. So that's going to be 2 times cosine x to the first power, and then times the derivative of cosine, which is negative sine x. So we've got negative 2 sine x cosine x, but oh my gosh, we're in trouble. But you should remember that the sine of 2x has an identity from pre-cal, and that's 2 sine x cosine x. So negative 2 sine x cosine x would be the negative of this, and that is why that is b. Alright, that's even a more complicated one. Here I actually have 3 functions. I have a function inside a function inside a function. It's functionception. That's hard to say. Let's see, I'm going to rewrite this as cosine of x over 6, all of that to the 6th power. So I've got 3 functions here. We work outside in anytime that happens. So my derivative is going to be 6 times cosine of x over 6 to the 5th power. That's the derivative of the outside function. Now times the derivative of the inside function, which is negative sine of x over 6. And then that times the derivative of the inside function, which is 1/6. So let's see, where is that here? So I've got a 6 and a 1/6. Well, those go away. So I need a negative. Cosine of the 5th, there it is, right there. Okay, here we're going to find a derivative at a point where we have to do the chain rule again. I've got a function inside another function. So my derivative is 3 times x to the 4th minus 2x plus 4 squared times 4x cubed minus 2. And we want to plug in the square root of 3. So we want 3 times the square root of 3 to the 4th power minus 2 square roots of 3 plus 4 squared times 4 square root of 3 cubed minus 2. Let's see if we can clean this up a little bit. So I've got 3 times the square root of 3 to the 4th is 9. And then the square root of 3 cubed is, well, 3 square roots of 3, but I'll bring the 3 out with that 4, minus 2. And I'm going to let you plug that into your calculator to see what this is. Anyway, so I want you to look at, when you come to my class tomorrow, that little sign of the guy I have on my little board, and it says the chain rule, or it says, yo dog, we put a function inside your function so you can derive while you derive. Anyway, I think it's pretty funny. So I will see you guys tomorrow.